Hello everyone, this video is going to be for chapter 4 lesson 3, which is about the rate of change and slope. Now as soon as I read the title of the lesson, you must be knowing what the lesson is going to be about because it's nothing new to you. You already know about slopes and also you know about the formula for slope, right? So again, just for a quick review, let's go through. Now in this particular lesson, they have asked you to use the formula of slope, which is rise over run. That is only for this particular lesson. But in general, if you get a question, find the slope, you can either use the formula, which is m equals y2 minus y1 over x2 minus x1, or you can use this, which is rise over run. Now, what is this rise over run? It's nothing. It's just that from one point to the other, how much do we need to move up and go to the right or to the left to reach the other point? It's just like walking. You start from here, and then to reach this point, how many units do you need to move? So here, the one which goes up, that's called the rise, because as the sun rises, the sun comes up. Same way, rise means to go up. So it's going to be 2 units. Rise is going to be 2 units, and then run, that's to the right, because you don't run up, right? You run to the right or to the left. So run is going to be 4 units here. It's as easy as that. So here the slope is going to be 2 over 4, which is equal to 1 over 2 if you simplify it. So that's rise over run. That's all. Now, is that necessary? You have to only take the rise over run from here? No, you can even take the rise over run from here as well. Doesn't matter. It's really not necessary that you need to go only in this direction. You can even go in this direction. That is, you can run first and then you can go up. You can rise. But then when you're writing that in the formula, you have to be a bit careful. Only difference is rise means to go up and run means to move to the right or to the left. Now, these are the types of slopes which you have already learned about in one of the videos previously. This is a positive slope. So if any line comes from the right corner to the left down, that means it is having a positive slope. And the other side, if it comes from the top right corner of left to the right down, then it is a negative slope. If it was a horizontal line, it has a 0 slope. And if it was a vertical line, we say the slope for this line is going to be undefined, because the line does not move to the left or to the right. It just keeps going up or down. That's all. So these are the 4 types of slopes: positive, negative, 0, and undefined. And then the formula for this particular lesson we are going to use is going to be rise over run. Right. So now let's get started with the questions here. Find the rise and run between each set of points, then write the slope of the line. Now already, to make it more simple for you, they have given everything. You just need to count. They even gave you the 2 points. So what you're going to do is you need to go up, because it's rise over run. The formula says slope equals rise over run. So to move from this point to this point, how many units do we need to move? That's what we are going to find out. So from here till here. To make it clear for you, this is for only one question I'll be doing this, okay? Because I want you to understand what this rise and run means. So what I will do is, from this point, I will extend it like that. And also from this point, I will extend it to the left. So you can see now where this point meets here. That's how much we are going to count. So from this point to this point, the rise is 1, 2, 3, 4. So the rise is a 4. And from the point where the 2 lines meet to this point, it's going to be 1, 2, 3, 4, 5. So the slope is going to be rise over run, which is 4 over 5. Simple, isn't it? So the same thing you will do here, but the points are different. Here it's going to be from this point to this point, or however you want, you can take it. You can take it from here or to here. So anyhow, we have to either move up or down first. Now to reach this point here, I need to move down. So which means it is going to be a negative rise. Negative rise means we are not going up, it's falling. Negative means it's falling down. So we are coming down. So let's come down. 1, 2, 3, 4, 5, 6. So the rise is going to be a negative 6. And then we go to the right. 1, 3. So the slope is going to be negative 6 over 3, which is equal to a negative 2. If you notice, can you see that the slope is coming from the from the left corner up to the right down? So which means this slope is having a negative slope. That's why we found the answer to be a negative slope, whereas here it's a positive slope, so the answer is a positive one. So it's always better, before you do this, decide whether the slope is going to be a positive slope or a negative slope. Then it will make it more easy for you. Now, for example, this question, is this going to have a negative slope or a positive slope? Of course, it's going to have a positive one because it's coming from the right corner up to the left down. So you go from this point to this point. So let's move up first. 1, 2, 3 points, 3 units to the rise. That's we moved 3 units up, and then 1, 2, 3, 4, 4 to the right. So the slope is going to be 3 over 4. That's all. You have to use rise over run to find the slope by using these methods. That's all. Now here again, it's the same theory, same formula we are going to use from this point to this point. Now this is a steeper line, right? It's a flat kind of line, not steep, it's a flat line. So from this point to this point, now again, to come from here to here, I need to move down. So which means it's going to be the rise, or rather fall, is going to be a negative 1 because you're coming down, and then you can see the slope is also from this side, so it's a negative slope. And then how about the run? So from here, 1, 2, 3, 4. If you have any confusion, simply draw from this point, extend the points, extend these points so that you will know. You have to count from the place where these points meet. In case if you get confused in any place, just extend these points, and where the two lines meet from here, you need to count. So 1 down and then 4 to the right. So the slope is going to be negative 1 over 4. Right? Now here, the rise. Is there any rise for this line? There is no rise. So the rise is going to be 0 because there is no going up or coming down. So there is nothing. But how about the run? We have 1, 2, 3, 4, which is 4. So the slope is going to be 0 over 4, which is going to give you a 0. Right? Now, if you remember, right in the beginning of the lesson, we did say that horizontal lines, see, horizontal lines have 0 slope. So this is a horizontal line as shown in the question, so it has a 0 slope. How about this one? Now we have a rise. Rise means going up. So we have 1, 2, 3. Wait, 1, 2, 3, 4, 5, 6. So the rise is 6, but there is no run. It's not moving up or down, so it's a 0. Sorry, it's not moving right or to the left. So the slope will be written as 6 divided by 0. Now, do you think you can divide any number by 0? Basically, 0 by itself is nothing. So we cannot divide this, which means there will be no answer for this, right? Because you cannot divide 6 by 0. So when you cannot divide 6 by 0, we say that the slope here is undefined because we cannot divide any number by 0. It's undefined. Alright, let's move to the next question, which is super easy. Tell whether the slope of each line is positive, negative, 0, or undefined. So this is the line. This line is going to have what kind of slope? It is a horizontal line, so they have 0 slopes. And this is a vertical line, so these kinds of lines have undefined slope. Just now we solved the question for a vertical line. Because we have to divide them by 0, we cannot divide them. So we say it's undefined. Now about this line here. It goes from the right corner up to the left down. So it is a positive slope. Alright, now the next one here. The table shows the amount of water in a pitcher at different times. Graph the data and show the rate of change. Between which 2 hours is the rate of change the greatest? First, let's graph it. So already the coordinate plane is given to you. You simply have to graph the points, that's all. So for 0, it is 60. That's here. For 1 it's 50, 2 it is 25, 3 is 80, so 80 is here, and 4 is 65, 4 is 65, 5 is 65 again, then 6 is 65 also, and 7 is 50. Now these are the amount of water in a pitcher. So we cannot find the graph unless we join them. So let's join the graph now first together. So always start from 0, then go to 1. Let me use a different color here because it will be visible. So 0 to 1, and then 1 to 2. So make sure you're joining that in the correct order. 2 to 3, and then 3 to 4, 4 to 5, 6, and then finally 6 to 7. So this is how your graph would look if you could draw. Alright, now from the graph, let's find out between which 2 hours is the rate of change the greatest. Now the rate of change is too much means it's going to be a very steep line. So from which time, from which hours is it very steep? Is this steep, or is this change a steep one? Or this one, there is no change, it's constant. But here it has increased, which means someone has put water in the picture again. So the greatest change, or the rate of change, is from 2 and 3 hours, right? So we just say 2 and 3, or between 2 hours and 3 hours, which means the same. So once you draw a graph, it becomes easy for us to find out the rate of change. If they ask for the greatest change, then you go for the steeper line. If they say no change, then we say it's constant, because we did learn all these words. Even during another lesson, we were interpreting the graphs. What do the graphs mean? So this is how easy this lesson was. I hope surely everyone would have got the answers right. So till we meet again, keep practicing.